Well, here in problem number 5, part C, we're asked to find the particular solution of this differential equation. Now, we've done this a bunch of times. Let's get started. We know that we're supposed to first separate the variables, get all the w's on one side and everything else on the other. So they have dw over w minus 300 equals 1/25 dt. Now let's integrate the left side and the right side. Using u substitution on the left side, we're going to get natural log of w minus 300 plus a constant. On the right side, we're going to get 1/25 times t plus another constant. We know we're supposed to get the constants together. So we're going to go natural log of w minus 300. Sorry, natural log of the absolute value, w minus 300. That's going to equal 1/25 t plus a third constant. Now, because we have one constant term, anytime from this point forward, we can substitute the initial values in to solve for this constant value. We can substitute now, or we can substitute later. Let's keep going and see what happens, because that's what we usually do. We want to get w by itself, so we're going to take and raise each side as a power of e. So we'll have the absolute value of w minus 300. And that's going to equal e to the 1/25 t plus a third constant. Now, using our algebra tricks, we know that this is going to be written as e to the 1/25 t times e to the c sub 3. And of course, everybody knows that a constant raised to a constant power is a constant. All right, and now let's get to work. Getting rid of absolute value bars. Oops. Getting rid of the absolute value bars. We know we'll get w minus 300 equals plus or minus this fourth constant times e to the 1/25 times t. Plus or minus an arbitrary constant is an arbitrary constant. So w will equal c times e to the 1/25 times t plus 300. Now we've solved our differential equation, and they tell us to state the domain. And I got to tell you, maybe they didn't tell us to. I guess they didn't. Okay. Well, if they did, I was thinking about that earlier, and it gave me trouble. But then I remembered in the initial problem statement, they told us that this differential equation would apply for the next 20 years. So our domain would be from 0 to 20 for the amount of time. Anyways, hope this is helpful. Thanks for watching the video.